Algebra Unit 12, Lesson 4, Notes 4, Piecewise Functions. A piecewise function is a function which is defined by multiple subfunctions. Each subfunctions applying to a certain interval of the main function's domain. The absolute value function can be considered a piecewise function. So it's like the line y equals negative x and the line y equals x. Okay, for x values greater than or equal to 0 and less than 0. Graph each piecewise function, then state the domain, range, and end behavior. So when we graph these, we have to look at these as separate functions, and it gives us an interval. So looking at letter A, I have f of x equals x plus 3 for all x values less than or equal to 1, and f of x equals negative 2x for all x values greater than 1. So what I'm going to do here is I'm going to create two separate tables here. One for the function x plus 3, and one for the function negative 2x. So let's draw a table. I want x values less than or equal to 1. So 1, 0, negative 1, negative 2. Because I have less than or equal to, I know that this has to be a closed circle. So I'm just going to write myself a little notation here and tell myself that this is closed. Okay. You can go ahead and plug x plus 3 into your y equals on your calculator, or just plug them in mentally. When I plug in each x value, when I plug in negative 2 plus 3 equals 1, negative 1 plus 3 equals 2, 0 plus 3 is 3, and 1 plus 3 is 4. Okay, I'm not even going to graph it yet. Let's take a look at this function. We are focused on x values greater than 1. So 1, 2, 3, 4. It doesn't include 1, so this will be an open circle. Again, writing a notation. And I know the open circle is at 1 because that's where my interval is. So negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. And negative 2 times 4 is negative 8. Okay. Now these x values and y values, for that matter, continue on. Okay, I'm only going to write a few so I can graph them. And similarly here, they're continuing on in the negative direction as well. So I'm going to graph these points. So my first set of points, I have negative 2, 1. So negative 2, 1. Negative 1, 2. 0, 3. And 1, 4. And 1, 4 is a closed circle. This is a straight line. So I'm going to draw in a straight line from this value all the way down to the left. And I'm going to draw an arrow down here, but not here. Because remember, we're concerned with just the x values less than or equal to 1. So let's go ahead and draw a line. Okay, and again, an arrow. So that's the first part, the x plus 3. Now let's look at the next one, the negative 2x. I have an open circle at the point 1, negative 2. So at 1, negative 2, I'm going to draw an open circle. Then 2, negative 4, the rest will be closed. 3, negative 6, and 4, negative 8. And again, I'm going to connect the dots. And draw an arrow in this direction. So all I did is I graphed two pieces of a function. Let's zoom out so you can see it here. Okay, so we have our closed circle here, our open circle here. Okay, it's like a continuation, except for I have to pick up my pencil, come down here, and then continue that way. So our domain, our x values, is definitely all real numbers. Our range, this one's a little tricky. For our range, the largest our y value goes is right here, which is at +4. Nothing else is higher. Everything is lower than that. So our y value, our range, is y is less than or equal to 4. It's equal to because it includes the 4. It's a closed circle on the y value of 4. And then our end behavior, as x increases, y decreases, or f of x decreases, and as x decreases, f of x also decreases. So these are both decreases. Go ahead and try letter B on your own. Letter B has a quadratic and also a line, horizontal line specifically at y = 3. Let's look at letter C. Here we have an absolute value function and a square root function. So again, I'm going to split this up into negative absolute value of x plus 5, and then square root of x plus 5 plus 4. Let's make our tables. Okay, our first part of the piecewise function is for x values less than -5. So -5, -6, -7, -8. You just want to do 4 or 5 points if you can. And we have for these, you can plug it into your calculator, into your y equals. So go to y equals, type in negative, and then hit the math button, arrow over once, and then it's option 1, which is ABS, which is absolute value, and plug in your x plus 5. Make sure the x plus 5 is in the absolute value bars. And then go ahead and go to your table and write down these values. Your values are -3, -2, -1, and 0. And we have here x is less than -5. It is an open circle. On the next function, we want x values greater than -5. So -5, -4, -3, -2, -1, 4, 5, I'm going to round to the nearest tenth here, 5.4, 5.7, and 6. Again, type that into your calculator, into your y equals. When I'm graphing, however, I'm probably going to skip right over these ones or do the best I can. I like to graph the more definitive points so I know that my graph is accurate. Okay, we have x is greater than -5, which means this is also an open circle. Let's go over to our graph and plot these points. Okay, so we have our first part of the function, -8, -3, -7, -2, -6, -1, and -5, 0. But remember, at this point, it's an open circle. And this is linear, so we are going to draw in a straight line. And of course, make sure we've got an arrow. Our next function is at -5, +4. So -5, +4, and that also is an open circle. Then -4, +5. -3 is 5.4, so roughly there, 5.7. It's very hard to graph those decimal points. And then 6. So this is a square root function, so it's a curve that goes something like that. And actually, let me redraw that a little. Okay, there we go. And an arrow over to the right because it's greater than -5. So this one's a little bit tricky for our domain. You might be inclined to say it's all real numbers, but I am missing one specific x value. Notice here, I have two open circles at -5. That means x cannot be -5. It can be everything except for -5. So there's two ways we can write this. We can write this as all real numbers except x cannot equal 5. I'm going to have to draw in a symbol there. So we can draw it in this way. Okay. Or we can simply just put our domain is x can't equal -5, and that would be sufficient. Our range, well, it looks like my graph here is definitely going on forever in the negative direction, and it appears to be going on forever in the positive direction. So my range in this case is actually all real numbers. Oh, actually it's not. I take that back. Looking more at this, it's not all real numbers because these values are not part of it. Okay? So because of that, we're going to write two statements here. It's y values that are less than 0 because they cap off right here. And it's going to be y values greater than 4. Our end behavior, as x increases, f of x also increases. And as x decreases, f of x also decreases. Oops. So there's a look at the whole problem. We'll do one more together. Let's take a look at number 4. This one has 3 pieces to it. I'm sorry, letter D, not number 4. Okay. So we do this the same way, we just have 3 separate functions we're going to graph within specific intervals. So this one I'm going to need a little bit more space. I'm going to break this apart into 3 different sections where we have the cube root of x plus 4. We have 2x plus 1. And we have -2 to the x. We're still going to draw in tables for each of these. Okay. Our first one, cube root of x plus 4. When you are doing this on your calculator, go to your y equals, make sure everything's cleared out. To get the cube root, you're going to hit the math button and go down to option 4. That'll give you cube root. And make sure x plus 4 is inside the cube root. Okay? All right, we want x values less than or equal to -3. So when I look at the table here, it's a cube root, so it's going to be a little tricky. There's going to be a lot of decimals. So taking a look, we have -3. That y value is 1. I'm going to keep going up until I have whole numbers. -4, which is less than -3, has 0. -5 is -1. And it looks like -6 is a decimal, so I'm going to write it in, but I won't necessarily graph it. We'll see where that takes us. Okay, it's a rounded value. All right, our next one, 2x plus 1. X values between -3 and +1. So -3, -2, -1, 0, 1. You can plug it in your calculator or do this one by hand. And we have -5, -3, -1, 1, and 3. Our last one is -2 to the x, and it's for x values greater than 1. So 1, 2, 3, 4. When we plug those in, we get -2, -4, -8, and -16. And we're not going to be able to graph that last one, but that's okay. The next thing I should do is determine whether we have open or closed circles. So up here I have x is less than or equal to -3, so it tells me that this one is closed. Over here, -3, it's open. And at 1, it's closed. And over here, greater than, this is also open. Okay, let's take a look at the graph. We're going to have 3 pieces this time. All right, -6, -1.26. I'm going to do my best. I would guess that's about there. -5, -1. 4, 0. I'm sorry, -4, 0. And -3, 1. Okay, and it is a closed circle. This curves down like that. The next piece, I have an open circle at -3, -5. So -3, -5. I have an open circle. -2, -3. -1, -1. 0, 1. And 1, 3 is closed. This is linear, so I'll use my line feature here. I'll draw on a line. Okay, no arrows, it's just a little piece in the middle. Okay, our next section, we have an open circle at 1, -2. And then I have 2, -4, 3, -8, and the 4 I cannot draw. And that one continues that way. Okay. Our domain. Because I have a closed circle here and an open circle here, there is an answer or a solution when I plug in -3. So the solution would be 1. Same thing here. Because I have a closed and an open, I'm good. That x value of 1 is included. Because this goes on forever in the negative and in the positive direction, my domain is all real numbers. My range, well, it does have a maximum y value. The maximum y value is 3. This piece is decreasing, and so is this piece. So this is the highest it will ever be. So I have y values less than or equal to 3. And our end behavior, as x increases, f of x decreases. And as x decreases, f of x also decreases. And there's the whole problem. Go ahead and try E on your own. It's another one that has 3 pieces.